see the problems of exponential distribution today. So this is first problem. Let x be a random variable with PDF. F of x is given 1 by 3 into e power minus x by 3. X is greater than 0. 0 otherwise. Find p of x greater than 3 and mgf of x, e of x and variance of x. Okay, let us do one by one the subdivision. So p of x greater than 3, which is integral 3 to infinity f of x dx. Because we know in exponential distribution f of x is defined in the interval 0 to infinity. It is defined in the interval 0 to infinity. Okay, but here it is 3 to infinity. F of x is given here 1 by 3. Take 1 by 3 outside. E power minus x by 3 dx. So when you integrate e power ax, e power minus ax, it is e power minus ax by minus a with 3 to infinity. 1 by 3 and 1 by 3 get cancelled. E power minus infinity 0, upper limit 0 minus lower limit. When you substitute lower limit, e power 3 by 3, which is 1, right? In denominator there is negative sign, e power minus 1. So e power minus 1 or 1 by e power minus 1 or 1 by e is the answer, right? 1 by e. If you use calculator and find the value, it is 0.3679. Okay. Let us do second subdivision, mgf of x. Mgf of x. Alright. Which is mx of t. The notation is mx of t. We know mx of t for this exponential distribution is lambda by lambda minus t. And lambda is given here, right? What is f of x? Lambda into e power minus lambda x, right? What is f of x of exponential distribution? Lambda into e power minus lambda x. Hence lambda is 1 by 3. So mgf, lambda is 1 by 3 by 1 by 3 minus t. Simplifying 1 minus 3t by 3. Where 3 in the denominator and this 3 in the denominator get cancelled. So which is mgf of x. Next we have to find the mean of this problem, right? Mean, e of x. And you know mean of exponential distribution, which is 1 by lambda. Just now I said lambda is 1 by 3. So which is 3 here. Okay, mean. And variance of this exponential distribution, what is variance of this distribution? 1 by lambda square. 1 divided by 1 by 3 the whole square, which is 1 by 1 by 9. 9 goes numerator, hence variance of x is 9. So which is the problem. Okay. Let us see second problem of this distribution. Find the mgf and rth moment of the distribution whose PDF is f of x equal to k into e power minus x. Find also the standard deviation. And how do we do? See, and here first let us find the value of k. Okay. So we know integral, it is minus infinite to plus infinite. F of x dx is equal to 1 by definition of PDF. So to find the unknown value, we use this unknown constant, right? K. It is 0 to infinity, we have function. We have function only in the interval 0 to infinity. Okay. So taking k outside, integrating e power minus x by minus 1, 0 to infinity. So it is upper limit e power minus infinity 0, upper limit minus lower limit. When you substitute lower limit, e power minus 0 is 1 and denominator there is negative sign. So it is 0 plus 1. That is 0 plus 1 is 1. Hence the value of k is 1. Okay. So what is our f of x now? K into e power minus x becomes e power minus x since k is 1. And the second question is answer mgf. mgf. We know mx of t for exponential distribution, which is lambda by lambda minus t. where lambda is 1, right? Sorry, right, lambda is 1, lambda into e power minus lambda x. What is f of x of exponential distribution? Lambda into e power minus lambda x. So lambda is 1. So 1 by 1 minus t, which is MGF of the distribution. Next it is asked the rth moment, that is mu r dash. What is mu r dash is asked there, okay? So to find mu r dash, there are many methods. You can use formula mu r dash, which is a expectation of x to the power r. And you can use integral x power r f of x dx. Integrate, okay? Or you can expand this. You can expand this, right? Let us write it as 1 minus t whole power minus 1. Use binomial expansion. 1 plus t square plus etc. See, coefficient of t by 1 factorial is mu 1 dash. Coefficient of t square by 2 factorial is mu 2 dash. Okay. Then coefficient of, similarly see, it is t power r by r factorial, which is r factorial into. I have to multiply and divide by. There is a term t power r. Okay. So you multiply and divide by r factorial plus etc. So what is mu r dash? Mu r dash is coefficient of t power r by r factorial. What is coefficient of t power r by r factorial? It is r factorial. So this is the rth moment. Rth moment is mu r dash. Once you know rth moment, you can find mu 1 dash, which is mean 1. Mu 2 dash, which is 2. And you can find variance. Mu 2 dash minus mu 1 dash the whole square, right? Here we have to answer standard deviation also. So variance of x is mu 2 dash minus mu 1 dash the whole square. Where mu 2 dash is 2 factorial. Mu 1 dash is 1 factorial. Variance of x is 1. Once variance of x is 1, what is standard deviation? Square root of variance of x, which is root of 1, and answer is 1. Okay. Let us see now the third problem. The time in hours required to repair a machine is exponentially distributed. So you read the sentence again. The time required to repair a machine is exponentially distributed. So what is the variable here? X is exponentially distributed. What is x here? The time required to repair a machine is x, which follows exponential distribution. Okay. With parameter, we know in exponential distribution, lambda is the parameter. The parameter is given, lambda equal to 1 by 2. So let us write here the answer. So x follows exponential distribution. What does x denote? X denote the time required to repair a machine. Okay. This is the variable which follows exponential distribution. Okay. So it is given the parameter of this distribution is 1 by 2. Once you know parameter, you can write f of x. F of x equal to lambda into e power minus lambda x when x takes values to from 0 to infinity. So here 1 by 2 e power minus x by 2 when 0 to infinity. It's 0 otherwise. Okay. So once you know f of x, let us read the question. Question: what is the probability that the repair time exceeds 2 hours? Repair time is the time required to repair a machine is capital X. Exceeds 2 hours. Repair time is capital X. Exceeds greater than 2 hours. What is probability of x greater than 2 is the question. Probability of x greater than 2, which is integral 2 to infinity f of x dx. The substitute and integrate e power minus x by 2 dx. Integration of e power minus x is e power minus ax by integration of e power minus ax is e power minus ax by minus a with limit 2 to infinity. This 1 by 2 and 1 by 2 get cancelled. We have negatives in the denominator. When you substitute upper limit, it is 0. Minus, when you substitute lower limit, it is e power minus 1 with negative sign. So answer is 1 by e. Okay. So if you use calculator, you will get the value of 1 by e. Okay. So this is first question. Let us read second question. See, what is the conditional probability that the repair time takes at least 10 hours, right? at least 10 hours. The repair time is capital X. Takes at least you know, at least is 10 and more than 10. What is 10? At least 10 hours is 10 and more than 10. That is greater than or equal to 10. So what is X greater than or equal to 10? Given that its duration already exists 9 hours. Duration exceeds 9 hours. That is X greater than 9. So it is X greater than 9. So it is given already the repair time exceeds 9 hours. So what is the probability that the repair time takes at least 10 hours? Okay. So if you write mathematically what it is, the question asked is P of X greater than or equal to 10 given X greater than 9. This is what the question. P of X greater than or equal to 10. Right? That is repair time exceeds at least 10 hours given that it already exceeds 9 hours. Okay. Let us use memoryless property. You know memoryless property, right? P of X greater than M plus N given X greater than M is equal to P of X greater than N. Okay. So listen here, in continuous interval, that in integration, listen here, whether it is greater than 10 or greater than or equal to 10, meaning remains same, right? It is a greater than 10 or greater than or equal to 10 in integration. We write integral 10 to, okay, meaning remains same. So let us use memoryless property. P of X M plus, this is our M. So 9 plus 1, which is M plus N. And this is M. So which is P of X greater than N. Our N is 1 here, okay. P of X greater than M plus N given X greater than M. X greater than M is equal to P of X greater than N. So it is 9 plus 1, okay. You can write 10 as 9 plus 1. 9 is our M and 1 is N. So if you write, listen here, it is integral 1 to infinity f of x dx. You know our f of x is 1 by 2 e power minus x by 2 dx. Just integrate and find answer, okay. Integrate, take 1 by 2 outside, e power minus x by 2 by minus 1 by 2 with 1 to infinity. 1 by 2 get cancelled, substitution of upper limit gives answer 0, minus of this minus which is e power minus 1. Hence the answer is, sorry, am I right? 1 by 2. It is 1 by 2. So answer is 1 by e power 1 by 2. It is minus sign. X is 1, so 1 by 2. So answer is 1 by e power 1 by 2. Use calculator and check. The answer is 0. It is 6066. Okay. Use calculator and check, which completes this problem. Let us see fourth problem. The mileage which car owners get with a certain type of radial tire is a random variable. So what is the capital X here? The random variable. So it having an exponential distribution. Okay. So X is exponentially distributed. What is this random variable X? The mileage from a certain type of tire. The mileage from certain type of tire is a random variable. So X denote the mileage. X denote the mileage of the car obtained from a tire, right? Mileage obtained from a certain type of tire. Let X denote the mileage obtained. It is given. This is a random variable which follows exponential distribution. Okay, with mean 40,000 given. So with mean 40,000. What is mean of exponential distribution? 1 by lambda. So 1 by lambda is 40,000, which implies lambda equal to 1 by 40,000. Okay. What is the question? Find the probability that one of these tires, okay, will last at least 20,000 kilometer. That is the duration of tire. Find the probability that the duration of tire is at least 20,000 kilometer. So it must work at least, should go at least 20,000 kilometer. The duration of tire must be at least 20,000 kilometer. Okay. So that is, listen here, we have assumed X as the mileage, right? The mileage should go at least 20,000 kilometer. So X greater than 20,000, at least greater than or equal to 20,000, which is integral 20,000 to what is the, it's in 20,000 to infinity, right? Infinity f of x dx. Okay, So this is our, we know in exponential distribution, the interval for x is 0 to infinity. But here it is 20,000 to infinity. So f of x is lambda into e power minus lambda x. Our lambda is 1 by 40. 1 by 40,000, okay. With the limit 20,000 to infinity. Taking 1 by 40,000 outside, integrating e power minus x by 40,000 by minus 1 by 40,000 with limit 20,000 to infinity. This 1 by 40,000 get cancelled. Upper limit answer 0, upper limit minus lower limit answer. For lower limit answer we have another negative sign. When 20,000 is for x, 20 by 40 is 1 by 2. 1 by 2. E power minus 1 by 2. So it is 1 by e power 1 by 2. So you use calculator and check what is 1 by e power 1 by 2. It is already I said, right? In a problem we met this kind of answer, which is 0.6066. Okay. We have to answer another question. See, the one of these tires will last at most 30,000 kilometer. So the duration of one of these tires is at most 30,000 kilometer. Okay. So at most, you know, what is the meaning at most? It is less than or equal to, right? It's equal to 30,000 or less than 30,000. That is at most 30,000. Okay. Which is, this is the question asked. Okay. It is f of x dx. So maximum limit is fixed here and hence minimum limit is 0. Because in exponential distribution we know x takes limit 0 to infinity. So lower limit is 0. So you can see f of x is 1 by 40,000 into what is that, lambda into e power minus lambda x. Lambda into e power minus lambda x is our, if you want you can write here, after getting lambda you can write f of x. Lambda into e power minus lambda x in the interval 0 to infinity, 0 otherwise. Okay. So lambda is 1 by 40,000 into e power x by 40,000 minus x by 40,000. So it is minus x by 40,000. Integrated 1 by 40,000 into e power minus x by 40,000 divided by 1 by 40,000 with limit 0 to 30,000. This 1 by 4, we have negative sign. These two get cancelled. Usually in all other problems, upper limit is infinity. So e power minus infinity 0 we will say. But here upper limit is 30,000. So if for x 30,000 and denominator 40,000, which is 3 by 4. So upper limit is 3 by 4, right, with negative sign. Okay. Upper limit, another limit, listen here, upper limit minus lower limit. So it's when you substitute lower limit, e power 0 is 1. 1 by minus 1, which is plus 1. 1 minus e power minus 3 by 4. And you use calculator and check, the answer is 0.5276. 0.5276. Okay. So which complete this problem. Let us do sixth problem. The daily consumption of milk in a city in excess of 20,000 liters is approximately exponentially distributed. So what is the random variable here? So what is exponentially distributed here? Excess of 20,000 liters, right? That is daily. If the daily consumption is 30,000, excess of 20,000 is 10,000. That 10,000 is exponentially distributed. Okay. So let us write in general. Let this daily usage, this 30,000 be y. So if the daily usage is y and the excess of 20,000, right? 30,000 minus 20,000 will give excess usage. So y minus 20,000, right? That y minus 20,000 follows exponential distribution. Let us write that y minus 20,000 as x. So y is the daily usage of milk. And daily usage minus 20,000 will give excess milk. That excess milk follows exponential distribution. So x is the excess amount of milk used. Okay. X is the, once again I tell you, see the daily usage of milk. If it is 30,000, assume daily usage is 30,000. Excess of 20,000. What is excess of 20,000 in 30,000? 10,000. That 10,000 is exponentially distributed. Let us write in general, this 30,000 is y. That y minus 20,000 is exponentially distributed. Let us assume y minus 20,000 be x. Okay. So y minus 20,000 is x. What is x? Excess milk used. Okay. Y denote daily usage of milk. Okay. Okay. What is the question actually? Question is, the city has a daily stock of 35,000 liters. Okay. City has daily stock. What is the probability that of 2 days selected at random, stock is insufficient for both days? Okay. Let us find answer for 1 day and then we shall find answer for both days. Okay. Stock is insufficient. What's the probability that the stock is insufficient? Stock is 35,000 liter. When the stock will be insufficient? When the usage is more than the stock is insufficient. Okay. When the usage is more than the stock. The usage is assumed as capital Y. So when the usage is more than the stock, when capital Y is greater than 35,000, the stock is insufficient. Okay. That is what the question asked. What is the question asked? Y greater than 35,000. This is the question asked. Y greater than 35,000. But Y is not exponentially distributed. Okay. X is exponentially distributed. What's the relationship between X and Y? Y is equal to X plus 20,000. Y is equal to X plus 20,000. Which is P of X greater than 15,000. Let us do integral 15,000 to infinity f of x dx. Our f of x is 1 by 3,000 e power minus x by 3,000 or 1 by 3,000 into x dx. Integrate, it is 1 by 3,000 into e power minus x by 3,000 by minus 1 by 3,000. That 3,000, 1 by 3,000 get cancelled. So it is e power minus x by 3,000 with negative sign 15,000 to infinity. You know e power minus infinity is 0. Minus, when 15,000 is substituted, 15 by 3 is, what is 15 by 3? 5. Okay. E power minus 5. You will see in calculator what is e power minus 5. So this is the answer for 1 day. 1 day. We have to write answer for both days. Okay. 2 days at random. Let us see the daily usage of milk in a city in excess of 20,000 liter is exponentially distributed. Okay. So if the daily usage is capital Y minus 20,000 is exponentially distributed. That will give excess. Capital Y minus 20,000 will give you excess milk used. That excess milk is capital X. Okay. So we have two variables here. Capital X. Okay. Which follows exponential distribution. And the average is given. Average is mean. We know what is given here. See the average. You know average of exponential distribution is 1 by lambda. Mean of exponential distribution is 1 by lambda. So it is given 1 by lambda is equal to 3,000 or lambda is equal to 1 by 3,000. Okay. Lambda equal to 1 by 3,000. So you write f of x, which is lambda into e power minus lambda x with this limit. What is the question? We have stock 35,000. The stock must be insufficient. When the stock will be insufficient? When the usage is more than the stock. When the usage, daily usage is more than the stock. Daily usage is assumed as capital Y. So when Y is greater than 35,000. Actually Y is not exponentially distributed. Okay. X is exponentially distributed. Let us change Y in terms of X. We know what is Y in X, right? Y is equal to X plus 20,000. So you find the answer. So this will give you probability that the stock is insufficient. Stock is insufficient for 1 day. Now we have to answer probability that the stock is insufficient for both days. Which is, see, it is independent, right? 1 day and another day. The answer of first day, the answer of second day will not depend on the first day answer. Okay. So it is e power minus 5 into e power minus 5, which is e power minus 10, which is the answer. Okay.